అది అలాగే అవుతాయి. Yeah, good morning. You can hear me, right?
Good
Yes,
morning.
sir.
Yeah, okay. So I think we are done with impedance of medium. Eta is equal to E naught by H naught. I
Yes,
remember.
sir.
Yeah, okay. So now we will see how we will prove this. That is intrinsic impedance of a medium. If I take eta, so eta is equal to, I know I have we are done with this. So we proved that mu by epsilon, okay? But in general, if you take a general case, eta is equal to j omega mu by sigma plus j
J
omega
omega.
epsilon. Did I complete this one?
No, sir.
Okay. So in general, we have this. So if I say lossless medium, when I say lossless medium, what is lossless medium for electromagnetic waves?
Free space.
Free space. So in free space means insulator. So for lossless medium, I would say sigma must be zero.
Zero, sir.
Yeah. So if I put sigma equal to zero here, then we get eta is equal to this. All right. So if I take low loss medium, when I take low loss medium, so in this case, sigma must be far less than this one, omega epsilon, right? Sigma must be
Yes,
far
sir.
less than omega epsilon. When I take high loss medium, if I take high loss medium, then unfortunately sigma will go beyond this, far greater than. So when you plug in all these things, you will get some different expressions for, I mean, in high loss and I mean low loss medium. So that we will see, and also we'll try to, and also we proved this one, right? That is, we understood how to obtain this wave equation for electric and magnetic fields. So del square E plus you have omega square mu epsilon E equal to 0. So I can choose this equal to k square, or I can choose it as minus gamma square. And also we found solutions for this. Solution for E is we got something like what, like say E naught plus e power minus jk dot r plus E naught minus this is a vector again, e power positive jk dot r. This is forward traveling wave and this is backward traveling wave. Similarly, also we can take for h equal to, also we get corresponding coefficient multiplied by e power negative j dot r, plus again I can take corresponding backward stuff. So these things also, I mean, we did. So if you put in the solution, if I take this minus gamma square in this case instead of this, then you will get what now? So we will get E is equal to like E naught plus e power minus gamma as a vector. We can take gamma dot r plus corresponding backward wave. So means we can do these things. Now what I'll do. So how did we start this? So we took two curl. So curl of h and curl of e. We took, and in this we use this, and we found all these equations. Okay, we will do this a bit. I mean, we'll do this somewhat differently in this case, and we'll try to see. We'll try to see this eta, that is j omega mu by sigma plus j omega epsilon under square root. And also in this case, what you have is this. And if I take this equation like this, like our equation del square E minus gamma square E, if it is equal to 0, now I know gamma is propagation constant, but the value for gamma is this. Gamma is equal to j omega mu plus sigma plus j omega epsilon. See, eta is equal to j omega mu by sigma plus j omega epsilon. Now, what is gamma? Just multiplication of these two components is gamma. So this also we will see in this revisions. Okay, we will come to this. We'll come to this, followed by this, and again this. We'll check these things now. Okay, so what I do again, I'll go for Maxwell's equations in phasor form. Take Maxwell's equations in point form, also integration form. And now also, of course, you have in phasor form, that is, I have first one say curl of H. J, what is J? Conduction current density means sigma E. Sigma E plus dou D by dou T. So phasor form means replace dou by dou T as dou J omega. So dou D by dou T, J omega epsilon E. Okay. And curl of E, curl of E is equal to what here?
minus j omega mu h, sir.
Okay, minus j omega mu h. And of course, I can take divergence of E. If I take source free, divergence of E equal to 0. I'm taking source free condition here. So divergence of B, the B is equal to mu h to 0. So I have curl and divergence equations for E and H respectively. Now, I just took a source free case in this case. So what I do, so I'll go for again same story. So spatial variation. So we will take this case. You have zt and hzt. What is the meaning of this? So propagation of E is along z axis. Okay, propagation of H is also along z axis. Spatial variation is along z. Like however we arrived at this, same thing also we take in this derivation as well. So same thing we will take now. So that is again curl of H is equal to now sigma plus j omega epsilon E. Okay, and into this curl of H now. So you have ax, ay, az, dou by dou x, dou by dou y, dou by dou z, and you have taken in Cartesian system hx, hy, hg. Okay, is equal to, so you have sigma plus j omega epsilon, you have ex roof plus ey roof plus az roof. Agree? So we assumed these things. That means dou by dou z of e of h. This is okay. Okay. So but dou by dou x, or dou by dou y of e of h. We don't want this one, right?
Yes, sir.
We made it 0. So therefore, wherever you find dou by dou x, dou by dou y, just trash them. Dou by dou x, dou by dou y gone. So now what you have? So what you have now? You have minus dou hy by dou z ax. Okay. So minus ay. So this becomes here dou hx by dou z ay plus this is 0 because this is just 0, 0 times az. So now you have, so now what do you have here? So you have sigma plus, okay, same thing, sigma plus j omega epsilon ex roof plus sigma plus j omega epsilon ay roof plus same thing az roof. Okay. Now just equate corresponding components for ax, ay, a0. Okay, so therefore, now what do you have for this? Let me cut this equation. So yeah, so I'll just put it here. Now you just tell me what you get for this. So I can say dou hy by dou z is equal to minus sigma plus j omega epsilon Ex. Agree? This minus we just brought on the right hand side. Yes or not?
Yes, sir.
Yeah, and also you have dou hx by dou z is equal to sigma plus j omega epsilon Ex. And here you have 0 is equal to Ez. So 0 is equal to Ez. And this is pretty straightforward. So what are we doing? Because we know this point very well. You have a transverse plane. Okay, you have a transverse plane like this. You have a transverse plane, and you have propagation this way. So this is your propagation. So this is what your xy plane on which you have transverse components like this. So what are transverse components here we have now on this plane? So you have Ex, say Hy,
Why, sir?
and Ey Hx. Yeah. So these transverse
Yes, sir.
components must be present. That means, see, I have Ex, I have Hy, I have what is this? This is Ey, right? This is Ey. Second one is Ey.
Yes, sir. Yes, sir. EY,
This
sir.
is Ey, and this is Hx. So I know very well that if I take a wave, I'm taking a wave like this, for example. Okay. For example, this is a EX oscillations. If you have EX oscillations on transverse plane like this, I have EX oscillations, and this is what my EX wave. So now along this z-axis, we have direction of propagation, that is k, along this z. So can I say now Ez equal to 0? I must say Ez equal to 0, and I must again say Hz equal to 0. So these components are longitudinal components. So these components are longitudinal components. So that means they must be 0. I must have only transverse components because you have transverse electromagnetic wave. Transverse electromagnetic wave means what? Direction of propagation must be always perpendicular to transverse plane and
Perpendicular
their
to
transverse components.
transverse.
Okay, so therefore this must be 0. If I take TM wave along g-axis, if it is propagating along g-axis, then I must make Ez equal to 0, Hz equal to 0. If I say Tm wave propagating along x-axis, then Ez equal to
EX,
0, sorry,
EX,
Ex equal to
yes, sir.
0 and Hs
What
equal
is
to
it?
0, just like that. So therefore, now pretty well. So we proved that along the direction of propagation, if it is going along z-axis, so Ez must be equal to 0. That we got now. Okay. So similarly, we will take a second equation. So now what I do, let me box it. So let me box it. See, directly how I wrote this. How can I say this is Z equal to 0? How can I say this? Okay, because see, what do we have here? So further you have sigma plus j omega epsilon. Okay, a wave is traveling in the medium. So in the medium, sigma, epsilon, they cannot be 0. Yes or not? In a medium, this cannot be 0. If medium exists means this must exist, right?
Yes, sir.
Right. And a traveling phenomena always have some omega angular frequency. So this also not equal to 0. So which one must be 0 now? The right
EZ.
hand side. This must be 0. There is no other choice. So this cannot be 0. So this cannot be 0. So this must be 0 now. So therefore Z equal to 0. So we came to know Z equal to 0. So let us box only this particular set. So now what I do, let me cut this. Let me cut this. I don't save it, not required to save. And this is set 1, okay? So I say like this. So this is say, this is set 1. So this is equation 1, this is equation 2. Similarly, also we can do this. See, what is second curl equation? You have curl of E is equal to minus j omega mu h. Okay, same, you just find its determinant here and just equate with this. Okay, so if you do this, you would get like this now. So if you do this, let me take everything out. So you would get like minus, you get same thing, just compare with this. So I'll simplify this. So you would get, so dou Ey by dou z is equal to, you get minus j omega mu hx. And similarly, what you get here, dou ex by dou z is equal to, here what you get, here you get, so this becomes a plus, you will get positive here because negative in the left, negative, sorry, negative on the left, negative on the right, that becomes positive. Here you have positive on the left. After simplification, you get this, and you have negative on the right. So minus j omega mu hy, and that's it. And you again box it. So let us box these two equations again. And then this is set 2. Okay. So again, you have two equations in set 1, and sorry, in set 2 as well. All right. So yeah, and in this case again, you get the same thing. You get again like this. So 0 you get on the left hand side, and minus j omega mu you get hz on the right hand side. Okay, can omega become 0?
No, sir.
No. So these two cannot be 0. These two cannot be 0. So therefore this has to be 0. So hz must go 0. So there is no second thought now. Okay. So therefore, in TEM wave, if it is propagating along g-axis, both longitudinal components EZ, Hg must be 0. So this is how you can prove. Okay, so you can go home, you can make it like this. Okay, if it is XYZ, I go right hand rule. So I take YZ because Y cross G equal to, so this is Y-axis, this is G-axis, and you can take X this way. So if you take this is of direction of propagation K, now you can just, what do? You can think like this, dou by dou x of E or H cannot be 0. Yes or not? If wave is propagating along x-axis, so I can include spatial variation along x-axis, right? This is the meaning, they cannot be 0, otherwise they must be 0. Dou by or dou by dou z, E or H must be 0, agree?
Yes, sir.
Yeah,
Yes,
so
sir.
just go home and practice for these things. You will get the equations accordingly. So now once you understand the basic, you can do anything. Mm. Having said that, you have set 1 and set 2 equations, and you have something like this. Now what I do, I just take 2 of 2. I just take equation 2 of Roman 2. That means 2 of this 2. So from this you find hy. From 2 of 2 you find hy. So negative 1 over j omega mu dou ex over dou c. So you have this. Now 2 of 2, you plug this in 1 of 1. Okay, and 1 of 1. So I want to plug in this case. So what is now 1 of 1? So dou by dou z, hy equal to what? Just plugging this hy here. Okay, hy here. So you get negative 1 over j omega mu. So you get dou ex by dou z is equal to negative sigma plus j omega epsilon ex. Okay, can I bring this j omega mu to, I mean, can I bring this j omega mu on this to this right hand side? Can I bring it or not? Can I bring this j omega mu to this right hand side?
Yes, sir. Yes,
Why?
sir.
How can I bring it?
Homogeneous.
Yeah, because you are considering wave propagation in a homogeneous medium. In a homogeneous medium, at every point within the medium, epsilon and mu, they are perfectly, say, independent of both position, that is space, as well as time. Otherwise, simply we could say in homogeneous medium, epsilon and mu are simple constants. So therefore, I can take them wherever you want. So now, for simplicity point of view, what I do, I just so I hope you have this snap. You took the snap of it. Let me take my black again. So this can be further simplified like this: dou square ex by dou g square equal to, so I have negative, negative become positive. So j omega mu. So this stuff multiplied by sigma plus j omega epsilon. So this is on the right hand side, you have ex. So now you have this beauty. Yeah, so this box the equation. Now what I do, I just cut this. So let me cut this. I don't save it, not required. So we have this equation ready. Okay. Uh, you have this equation. Okay, I must take this color. Let me take this color. So can I say now? Can I say from this dou square ex by dou g square? Now I'll take this stuff. So this multiplication stuff, we will take it as gamma square ex. Agree? Now can you compare with this? So you just compare with this del square. Let me take in general del square e minus gamma square e equal to 0. So I resolve this e in terms of ex, ey, ez. So I have scalar equations, okay? So del square ex minus gamma square ey, sorry, ex equal to 0. Del square ey minus gamma square, symbol I can take del square ey minus gamma square ey, del square ez minus gamma square is equal to 0. Or I can take a one scalar like e, or ex, ey, ez, and I can show like this. That is what you have. And from this, I can say del square E is equal to gamma square E. Agree? Agree.
Yes, sir.
So now as this capital E is scalar, so I can take Ex. I can also find for Ey. I can also find, okay. Uh, Ez, okay. Ez anyways equal to 0. I don't want that because I have transverse components Ex and Ey. So I have Ex, Ey. And also we can find for the same equation is also true for hx, hy. Agree? Here also you have, hx, hy. Yes or not? So you have all set of scalar equations. All right. So you have this, and you know how to find solution for this. Whenever you have partial derivative, yeah, with space and time like this, then what do you have? Solution will be what here?
Exponentials.
Yeah, you have forward and backward traveling waves. Agree? That means you must have like this. So I find for ex, I take only forward traveling. If I take only for, let me take both now. So I can say like this, say ex naught plus e power minus gamma. What do I take now? Minus gamma z, okay?
Yes, sir.
Minus gamma z plus I can take ex naught minus e power a positive gamma z. Because the wave is traveling in the forward direction, positive gamma j means backward direction. See now, what you have to note down here, see please don't confuse here. Whenever I'm taking like this, generally this is a complex quantity. The coefficients, whatever you have, they're always complex in nature, every time. That means slowly I can put down like this, ex naught plus is equal to some ex naught plus I take magnitude as well as phase. Some phase I'll take like this. Agree? I have amplitude as well as phase terms associated within this complex term. Okay, so that is the intention. So when I take some phase here, now what you get, you will get some initial phase for this forward traveling wave, or you can take some initial phase for this backward traveling wave. Otherwise, you can make this phi 1 equal to 0, so that there is no initial phase. It all depends on what are we going to introduce in the analysis. Okay, if you want to make something complex, just put this. You want to make something simple, just remove this. Okay, so can I say that means I just did for that? Can I do for this same? Yeah.
Yes, sir.
So therefore, what I can do now, I can say that Ey, I'll take only forward traveling wave. Now I can say Ey is equal to, agree? Similarly, I can take Hx equal to Hx naught e power minus gamma z. And similarly, Hy is equal to Hy naught e power minus gamma z. Agree or not? You agree with this?
Yes, sir.
Okay, so so what is the first? You just tell me the. Okay, just a minute. What is one of one? You have uh, equation one of Roman one. What is this equation you have? What equation you have here? Dou Hy by dou z is equal to what do you have here? Negative sigma. Okay, actually, to remember things, you have negative here. On the right hand side, of course, you have positive term. Yes or not?
Yes, sir.
Transverse component Hy, so its transverse is Ex. Of course, Hy, Hs also transverse. Ex, Ex, Ey also they transverse to each other. So now, what I'll do? So what I do, I just take this. So I have Hy here. So Hy is equal to this forward traveling wave solution. So just find it now. So minus dou by dou z. So you have Hy naught e power negative gamma z is sigma plus j omega epsilon px. It is okay, okay, just like that. Now what do I do? Let me differentiate this. So I differentiate this Hy naught e power minus gamma z, differentiating with z. So I have what I have now. Yes, Hy naught e power minus gamma z minus gamma. You have of course minus u. Agree? So this is equal to sigma plus j omega epsilon ex. So these two become positive. Now how can I replace this? Because I know already Hy is equal to Hy naught e power minus gamma z. So therefore this turns out to be what? Again Hy. Agree? Again Hy multiplied by gamma is equal to sigma plus j omega epsilon ex. Now what is gamma here?
Sir, j omega wave into
Yeah,
sigma
so
plus
gamma,
j
this is
omega.
nothing but gamma square. Okay, dou square ex by dou g square equal to gamma square ex. So if I take this one as gamma square,
Oh,
the gamma is equal to square root of this multiplied stuff. So just take a snap of it if you want, because I want to remove this one. Can I remove this portion? Can I remove this portion? Please take a snap of it if you want. I'm removing this. Can I remove? Can I remove? Okay, yes, I'm removing this. Maybe you're not ready or ready, I don't know. Just remove this. Okay. So all right. So when hy is this, so can I say I'll take this way ex over hy. Ex over hy is equal to what do you have? Gamma over sigma plus j omega epsilon. But what is gamma?
Root
Gamma is
over
equal to, yeah, square root of j omega mu by sigma plus j omega epsilon. This is gamma divided by sigma plus j omega epsilon. If you simplify this, so Ex by Hy is nothing but what? Ratio between E and H is nothing but eta. Intrinsic impedance we call. This is nothing but, or simply you can say impedance of the medium. The word intrinsic we can use for free space or vacuum. That is already proved, right? For free space, what did you have?
root over
120 by,
pi, sir.
or approximately 377 ohms for free space, right? This is for free space. Or I can take vacuum. When you excite a medium by electric field with amplitude and phase, this medium will respond with a magnetic field, oscillating magnetic field with certain amplitude and phase, may be different from electric field's phase and amplitudes. Okay, anyway, so eta is equal to, now if you simplify this, you would get j omega mu divided by sigma plus j omega epsilon. Agree? This is the most uh, general equation. Let me box it. Right? This is the most general equation. You can designate this equation by, this is by 1, this is by 2, this is 2, say. Okay? Now, Ex by Hy is equal to, we have that. Now, can I take, what is Maxwell's equation 2 of 2? Just help me out here. Maxwell's equation 2 of 2. I'm going to the next page. I'm going to the next page here. I did not save anything. I don't save things now. Okay. What is Maxwell's equation 2 of 2? See, moment ago we considered Maxwell's equation 1 of 1. Now just take from 2 of 2. What is this equation here? 2 of 2 equation is what? Yes? Anyone please? Just tell me. We did know. What is this? Dou Ex by dou Z equal to what? Dou Ex by dou Z equal to what?
Sir, minus j omega mu into hy.
Okay, minus j omega mu. Good. Its transverse component is Ex is Hy. So we have this. Now, already we derived solution for Ex. Ex equal to what? We just took only forward traveling wave. E power negative gamma z. So therefore, I do this. Dou by dou z of Ex naught e power negative gamma z is equal to minus j omega mu hy. So what I get now, if I do e power negative gamma z, you get again ax naught, you get ax naught. Let's take 2 of 2. I just initially took one of one, right? For the first case, I took one of one, right?
Yes, sir.
Okay. So what is, I mean, one of two? Because if you do this again, you get same answer. Okay. See, if I take two of two, ex naught e power minus gamma z. So what you have here, minus gamma is equal to minus j omega mu hy. So this is done, and I can replace this by what you have.
Ex.
This is Ex. You have gamma is equal to j omega mu hy. If you want eta, eta is equal to you have Ex by hy. So now again, Ex by hy means what you have here, j omega mu by gamma. If you solve it, what you get? If you solve it, then what you get? J omega mu sigma plus j omega epsilon. What do you get if you solve it here? Please
Root
confirm
or
me.
j omega mu by sigma plus
Same
j.
thing, right?
Yes, sir.
So again, you get same thing. So I can do. I have four equations in two sets: Raman one, Raman two. In Raman one, I have two equations. In Raman two, we have two more equations. Put together four equations. You can just play by plugging these things like ex, ey, ez, whatever you want. You can plug in and get the things. But I want a little different now. Now, so as of now, I know eta is equal to ex by hy. But let me consider equation 1 of Raman 2. So what is this equation 1 now?
Sir.
So I have minus dou ey by dou z is equal to I have minus j omega mu hx. Agree?
Yes, sir.
This is what you have. So now I plug in this ey. So what is my ey now?
Ey naught into
Uh, ey
e
naught
power minus gamma z.
e power minus gamma z is equal to j omega mu hx. So just differentiate this, you get minus gamma ey. Agree? Just do like this. You get minus gamma ey is equal to j omega mu hx. Now, now let me take this ratio ey over hx. So what do you have now here? You have minus j omega mu by gamma. So happily we can say now eta is equal to minus ey by hx. I'm just putting this minus here. So that is this minus ey by hx. And now you have j omega mu by sigma plus j omega epsilon. Accepted. So, so with this, let me save it. JRDF. So finally, finally, mm, what we have, eta, eta is equal to what here? Ex over hy. Otherwise, otherwise what? Minus ey over hx. Agree?
Yes, sir.
Yeah, this is really important. Positive ex over hy is equal to negative ey over hx equal to eta, because this combination, I mean this is nothing but j omega mu by sigma plus j omega epsilons under square root. So now you know this is your impedance of the medium. So this is impedance of the material, I can say. Yeah. So you just tell me, if there is a medium in which I'll take a simplest case. I just put eta equal to 1. You know what is the meaning of it? Anyone? If you excite this field by an electric wave, suppose by any wave with certain amplitude and phase, you know what happens? This medium will respond to this excitation with a magnetic field, okay, with a magnetic field with same phase. Are you able to understand this? If eta is equal to 1, if eta is equal to 1, the medium also will respond. That means there is no phase difference between this electric and magnetic field. Yeah, so you will understand this, and also amplitude may be again same. Generally, amplitude of E and H will be same if eta is equal to 1. Agreed? Yes or not? Because if
Yes,
Ex
sir.
is equal to Hy in amplitude, eta is equal to 1. Otherwise, whenever you find something not equal to 1, a medium in which eta is not equal to 1, then obviously what happens here? An excited electric field. For this, medium will respond with different amplitude for the magnetic field. Agree?
Yes, sir.
Yeah. Now, again, you will understand one more thing. If you have two media separated by interface, medium 1, medium 2, if eta 1 is not equal to eta 2, if eta 1 is not equal to eta 2, then what happens, you know? If a wave is incident at the interface, now definitely you will get reflection. That's it. 100% you will get reflection. Of course, some part will go into medium too as well, but you will definitely get reflection. So whenever there is impedance mismatch, reflection is 100% possible. Okay, 100% sure is a reflection. So that you will see again in the latter stage. So again, anyways, we are taking extra classes to complete the course. I just don't want to rush in these things because, as I told again and again, this is very important for gate point of view and for higher studies. Okay, Unit 4 and 5, they will decide your fate in this field. If we ever want to excel in this field, you cannot forget unit number 4 and 5. They must be with you. So okay, so so. Now I can categorize like this. So let me take lossless medium. Now you take lossless medium. Now, I'll take it like this. Instead of this. So I'll take this way. So what I have, let me put first of all my eta. My eta is equal to j omega mu by sigma plus j omega epsilon under square root. So let me confirm this first. Okay, now I take a medium. So let me take a medium. Now on one hand, say I have ideal case, that is lossless medium. On the other hand, I have say lossy medium. Okay, lossy medium. Say again, when I say lossy, again I can say I have low loss case and I have high loss case. Okay, high loss medium. So when I say low loss, so again in our subsequent lectures, this will be evident. That is, you would say sigma by omega epsilon is nothing but you will give a name for this ratio. That name is loss tangent. Okay. Remember this for now, but we will prove it how it is, how this ratio is called as loss tangent. Now we'll prove it. Uh, Actually, this of course we get from conduction current density and the displacement. If I take them in scalar forms, what is JC here? Sigma E. What is JD? You just take in phasor form, dou d by dou d, right? So J omega epsilon E. Okay. If magnitude of JC is equal to magnitude of JD, if If this happens to be true, I take its magnitude equal to magnitude of this. So you have sigma e. What is this magnitude here? What is magnitude of j? It's 1, right?
Yes, sir.
Yes or not?
Yes, sir.
Yeah. So now if I take this ratio, sigma by omega epsilon equal to 1. Okay, anyway, sigma is equal to omega epsilon. We will meet with this condition later. If you have this at the interface or in a medium, if you have this, then you will get this one. So if I take a lossless medium, sigma equal to 0, so we don't, I mean, but anyways, I'll not discuss this now. This is a different aspect of EM wave phenomenon. So this is really intriguing. Okay, you have an intriguing phenomenon. So I mean, what I mean by intriguing is interesting, fascinating. Okay, so we have this. We will understand this later. Okay, so if I take lossless, generally if I take lossless, then sigma equal to 0. Yeah, very happy. Lossless. If it is high loss, sigma is
Infinite.
approximately infinite. Yeah. So if it is low loss, sigma is very small. Okay, that's it. So we take lossless like this. So in lossless medium, what is my eta now? Eta is equal to simply, if I put sigma equal to 0, you get,
Root or mu by epsilon.
I can put down for like this. So 0 plus j omega epsilon. So this is gone. So you have mu by epsilon. This is what in lossless medium generally. Yeah, permeability, medium permittivity. Take these two parameters, take the ratio, put them and square root, get the answer. Now, if I take low loss medium, when I go for low loss medium, now that means sigma by omega epsilon equal to 1. Yeah. If it is 0, it's very happy for lossless. See, for lossless medium, if sigma equal to 0, loss tangent is 0. Okay. So for low loss means sigma by omega epsilon should be far less than 1. Agree? Agree.
Yes,
Low
sir.
loss. Yeah. And in this case, okay, don't worry. As of now, we don't know why this loss tangent or whatever about this loss tangent. You don't know anything about this, but just accept this because I know this guy is in the numerator. So I must really tackle this guy anyways. So lossless means must be 0. Loss 3 means high loss, again low loss we have. So this must satisfy this. And for high loss means what? Far greater than
Far
1.
greater than 1.
So just know these things. So in this case, lossless means I made this sigma by omega epsilon equal to 0. This is for lossless case, loss tangent equal to 0. And this is the case. Okay. So now, what happens to my eta now? If I just take this case, eta is equal to j omega mu. What happens now? By I have sigma plus j omega epsilon. Sigma is far less than. If it is far less than omega epsilon, then can I eliminate sigma approximately? See, you have sigma and omega epsilon, okay? Now, sigma is far less than omega epsilon. If sigma is so insignificant when compared to this, can I remove this guy approximately? Yes or not? So then
Yes,
I
sir.
make this approximately equal to. If I do so, I'll make it approximately equal to. So then I have j omega epsilon. So now again, so finally what I have is eta approximately equal to this. All right. So for lossless and low loss, impedance of the medium is behaving like this. Okay. Now coming to here, a strange phenomena will takes place. That is, uh, because we don't want this, but we have to. There is no second thought. So sigma is far greater than omega epsilon. Then what do? I can't eliminate this sigma. I have to account this sigma somehow. Okay, so when sigma is far greater than this, then what do? I can eliminate this one, right?
Yes, sir.
So now in this situation, eta is approximately equal to j omega mu by sigma under square root, approximately, because we just remove this guy deliberately. So eta is this. What is the meaning of this? So this is nothing but, let me put down like this, omega mu by sigma under square root. And what is square root of j in terms of angle?
Minus pi.
No, no. What is square root of j in terms of angle? I can take 45 degrees. Okay, see, if I ask you what is the question, I mean, what is I power 1?
I, sir.
What is I square?
Minus 1.
What is I cube?
Minus I, sir.
What is I power I? This is this is somewhat mm, this is somewhat for you. See, if you want this mathematical stuff, of course, I did not tell you this until now. But whoever knows, it's okay. But whoever doesn't know, uh, I have a channel on this YouTube channel. Again, I stopped it. I mean, almost 3 months. I just started this some 3 to 4 months ago. It was active for 1 month approximately. Then I stopped it because of my laptop issue, and again I kickstart it very soon. So what you do is, if you want, I'm just trying to unlock various mathematical stuff. And initially I started with very simple mathematical aspects, but now I will introduce engineering mathematical stuff. So I have this channel, machine versus mathematics. So there you will get uh, many things. If you want to subscribe, you can subscribe, and you will get. So in this, what is my main motto is, just unlock mathematical stuff. So is mathematical is we will check, we can find in this. And also I'll try to means I'm solving some gate problems, previous year gate problems I'm solving here. As I told you already, I just stopped it for 2 months. Again, I will resonate the form, maybe by this month end. Again, I will start this one again. Because I have my laptop now. I have my stylus pen as well. So I will record things and I will upload things in this channel. And especially because people struggle most in electromagnetics. So electromagnetics. So all advanced topics of this, antennas and waveguides, transmission lines. And interestingly, you have something called as computational electromagnetics. So computational electromagnetics, where I don't require to use any calculus. With the help of linear algebra itself, we can do these things. So I will discuss these things, and along with this, I'll discuss. I like this subject. I like electromagnetics and signals and systems. So signal systems and signal processing. So this is the only thing I cover. I just don't do anything. And also I'll give room for space administration. Okay. So some interesting aspects of space theory and all. And if there is time and interest, I'll go for also particle physics. But mainly, this is aimed at this stuff and this stuff and this stuff. That's it. This is the main aim. And these are just side things. Okay, these are secondary, but this is cardinal. When I say cardinal, it is at high level. And the most important thing is these areas. Yeah. So if anybody want to subscribe and watch, just go ahead. and do this. I just solved some network theory problems, simple some gate problems, strategy how to solve things. I just gave, and you can find something. Okay, you can just go ahead with that if you want. So in this, in that I gave this I power I. Okay. Anyone? What is I power I? Anyone, please? Most of us think I power I is something and it has single value, but I just explained there I power I is not a single value, it is a set of values. I power I is a set of real values. Interesting, right? If you find I power I, if you want to evaluate this, I power anyone in the class? Anyone, please? So, can I do this way? What is I? Can I take I is equal to e power I pi by 2? Can I take I is equal to e power I pi by 2? What is,
Yes,
Yes,
sir.
this
sir.
is what cos pi by 2 plus I
I
sin pi by 2. Cos pi by 2 is 0, sin pi by 2 is 1. So I into 1 is I. So I will take like that, and this is power I again. So this is now what you get now e power negative pi by 2. Agree? Because I square equal to 1, you get e power negative pi by 2. Now what is e here? E is around some. So what is e now? E is
2.7.
something like 2.7182818284 so on. Okay, divided by minus pi by 2. So what is minus pi by 2? Say minus 3.1415 so on by 2. Okay, now what are we going to get now? What are we going to get? You will get some real value, right?
Yes, sir.
Yes or not? Yeah.
Yes, sir.
But if you want further answers for this, you don't have only one answer for this. You will also have a set of answers, because not only for e power I pi by 2 it is I. Agree? Not only for this. What is e power I 3 pi by 2? What is e power I 3 pi by 2? What is e power I 5 pi by 2? So on. Are you able to understand this?
Yes, sir.
Yeah. Instead of this, just put various stuff, and accordingly this will change, right? So accordingly this remains same, but this will change. Agree? Agree?
Yes, sir.
So you will get different possible values for all real values you will get, but different. This is really interesting. If you this is anyways, I will make a video on this significance of I, because why do we study some variables like this x plus or minus jy? I just want to give a physical picture for this. So that's it. Yeah, physical picture. And also, I am doing videos. You can check my channel. There are videos on Vedic mathematics. Vedic mathematics. I did some 5 to 6 videos. So Nikalam Sutram, all those things I explained in the first video. So all those sutras and sub-sutras, you have 16 sutras and 13 sub-sutras on the Vedic mathematics. You can also solve calculus and geometry, all these things using the Vedic mathematics. You know what? If you learn these things, what happens? You will never by heart any mathematics. You will slowly, you will soothe. You can soothe, or you can soothe yourselves in this journey of mathematics. That means you can develop new models. If you are inclined to this Vedic mathematics, you can develop new models on your own. For that, you do not refer the existing models, okay? But you can just develop some new models on your own. Yeah. For example, why Earth is rotating about its own axis. Yeah. This will also help you. All these things definitely help you. You can get some solutions out of that. So, anyways, why did I tell all these things? Because we want to know square root of j. Okay, what is square root of j now? Now you tell me, what is square root of j now? Or what is square root of I? Can I say, okay, let me take this. So square root of j or square root of I, both are same, right? Imaginary terms. So Can I say j is equal to like e power j pi by 2? Can I say this?
Yes.
Yes, sir.
Yeah. Now square root means what? All power 1 by 2, right?
Yes, sir.
Now what is this? E power j pi by 4. Agree?
Yes, sir.
That's it. So in polar form, I can make it 45 degrees. Yes or not?
Yes, sir.
So you have eta in polar form, magnitude of eta is equal to, this is unfortunate stuff. Omega mu by sigma is really unfortunate. And the most unfortunate point here is 45 degrees. You know what happens? Because there will be a phase difference of 45 degrees between E and H. Between E and H in a lossy medium, in a high loss medium. Yeah, when there is a phase difference of 45 degrees between E and H, that's it. Now its course of propagation is okay, but significant power it cannot carry now. Most of the power will go waste. So therefore you would see that exponential decay in its course of travel. When EM waves are trying to travel in high loss medium, they just go like this. Okay, so that you will see. And impedance is not a very big reason for that, but the very big reason is alpha. So because in high loss medium, alpha is high, so attenuation constant is high. So therefore, if I say like e power minus j k dot r, this indicates what? Oscillation like this, right? Now, if you really multiply to this e power, I mean, what are oscillations? If you multiply by this negative alpha, some says g. Now, what happens if wave is traveling along g axis? Now, this e power negative, see this e power, this red one indicates pure oscillations like this. Because of this e power negative alpha z, now you know what happened? This red wave will become like this. Are you able to understand this? Yes, the blue wave, it's decaying like this. And how eta can also influence this change or decrement in power, all these things we'll understand. But one thing is true, there is no phase difference between like E and H, or there is no phase change between E and H when we consider this lossless or low loss medium. Yes or not? But there is an extra phase change of 45 degrees between E and H when you go to high loss medium. All right, all right.
Yes, sir.
Yeah, so this is what important point to note down. Okay, so we are done with this. So in the next class, what we do, we will, because I know that gamma is equal to square root of j omega mu and sigma plus j omega epsilon or square root number. But what is gamma? Gamma is like alpha plus, because it's a complex number, so it is like alpha plus j beta. Okay. Now individually we need to find alpha for lossless medium, alpha for low loss, and same alpha for high loss. And also beta, beta means phase constant. So beta, this phase constant is also equal to wave number in free space or vacuum. If you take any other material media, you can't equate beta and wave number. So beta is equal to wave number only in case of free space or vacuum. Okay, you take any other electrical media, whatever. So you cannot say phase constant and wave number they're one and same. That's incorrect. So beta also we find for lossless medium. Beta we should find for low loss medium and also for high loss medium. So when I have information about alpha and beta in this media, lossless, low loss, and high loss media, slowly you can understand the concept of dispersion and non-linearity in the medium, and also you'll understand something like phase velocity and group velocity. Okay, if something is traveling really fast, and that is what phase velocity. If something is not traveling that fast, you have to suffer in terms of group velocity. Okay, so you will understand this of course in communications also in the next semesters. So group velocity and phase velocity terms. So phase velocity will account envelope transmission, group velocity is remaining frequencies transmission. Okay, all frequencies they just don't travel at same velocity. If you take lossy medium, if you take lossless medium, all frequencies will travel at same velocity. So these things we will experience in our subsequent lectures. Okay, so and we will appreciate how the formulas for alpha and beta were developed, so that alpha will take into account all these parameters omega, mu, and sigma. The same parameters also we encompass or we include for beta, but beta will talk about phase accumulation. See, this is lovely because we use same parameters omega, mu, epsilon in the formula for beta, but still that information will just engross phase accumulation. But the same formula in different way, that will talk about attenuation. So we will develop those two formulas, and then we segregate those formulas for this medium, and that's it. That will complete our unit number 4. And unit number 5 is that's a short unit. It's a very simple unit. So whatever you have learned here, directly apply them at the interface. That's it. Now at the in unit number 5, we will take more than one medium. You can take one medium. You can take interface between two media, or you have two interfaces between, say, among three media. Okay, so on we'll take, and then we will understand here perpendicular polarization, parallel polarization. Okay, so an instant wave, and also I think we need to learn with polarization. So your class here, Niharika texted me that uh, uh, up to what time you have class today?
5 o'clock, sir.
Oh, this is horrible. Why are you having class up to 5 o'clock here?
Sir, we are having signals and systems lab, sir, today.
No, no, I'm not asking for today. I mean, usual days from Monday all the way through Saturday.
No, sir, only Friday
4 p.m.
itself 5 o'clock.
Okay, so I mean, what about EDC subject? Did sir complete that course? EDC or mathematics? Did anyone complete course here? Any idea? Did anyone complete course or about to complete course in one day or two?
Sir, maths sir said he's going to complete in other 2 more hours.
Okay, then if that is the case, Manoj and Niharika, please ask him so that we will try to occupy that class. Okay.
Okay, sir.
Okay, sir.
So when is your mid examination?
24th. 21st, sir. 21st, actually.
Okay. Okay. It starts from 21st, right?
Yes, sir.
And ends at, it's going to end on what date? 23rd. 23rd, right? Okay. So when is your end examination?
From December 28th, sir, semester examination.
Okay. Okay. So, anyways, we need, as I already told you about the number of classes that we require. So please try to see to that. I just want to club section C also with you, section A and section C, so that we can just take a one go. Okay, so please make it fast, because I think I require hereafter, I require total, means including our actual hours. So I require some, okay, I require some 12. Yeah, so including, so do we have class tomorrow? Do we have class tomorrow?
Yes, sir.
Yeah, so I think we can get 2 classes tomorrow. So if so, including this we require 12. Okay, so Manoj and Niharika, please look into it.
Yes, sir.
Okay, thank you.